Intercepts today, solving graphically and algebraically. The intercepts are the points where a graph intersects the x or the y axis, which I hope you know. But what I really like to talk about is the connection between the ordered pair and how we do things algebraically. So an x-intercept occurs where a y is equal to 0. The y-coordinate is equal to 0. And you can see that on the graph here. Here's my x-intercept. The ordered pair for that x-intercept would be something for the x value and a 0 for the y. And so when you think about the graph and think about the ordered pair, this ordered pair tells me exactly what I need to do to figure out the x value. It says, hey, make the y value 0. And so over here, we have another x-intercept, and if I think about that ordered pair, it would have some number in place of the x, a different number, like a 1 or something, and a 0 for the y value, okay? You grab and go? Can you bring it back here real fast? Yeah? I'm just going to keep going now. Make it quick. Yeah, you're missing notes. Okay. Full throttle here. Okay. So the y-intercept occurs where an x is equal to 0. Exactly. And again, when we think about the graph here is where our graph is crossing the y-axis. That is the y-intercept. And if you think about the ordered pair, it would have a 0 for the x and some value in place of the y. And again, making that connection to the ordered pair and where the zeros are is the best way to think about intercepts. A function can have 0 or more x-intercepts. If we had a very cubic function like this, it would have 1, 2, 3 x-intercepts. It could also, maybe I have a parabola that's floating up above the axis and we have 0 x-intercepts, okay? That would be imaginary because they're not really there, okay? They're imaginary intercepts, all right? So we can have 0 or more intercepts. Now, for a y-intercept, there is at most one y-intercept. How come we can't have a function that has 2 y-intercepts? Like here, this is an example. It doesn't, it's not a function. It's not a function if we have more than one y-intercept, okay? And so there's always only one y-intercept, okay? Only one y-intercept. So very simply here, graphically super easy to identify our x and y intercepts. And so always when we're finding x and y intercepts, algebraically we're going to do a lot of math. Can we check our answers? Absolutely, because when in doubt, graph it out. And I'm going to show you how to do that. I want you to be able to check your answers. Where on number 1, what's our x-intercept? Yeah, and I want that as an ordered pair, 4, 0. I want you to write intercepts as ordered pairs because, again, I want you to make that connection between the ordered pair and how we solve things algebraically, and that ordered pair is really going to help. What's the y-intercept? 0, 2. Beautiful. Let's look at number 2. How many x-intercepts do we have? 4. 1, 2, 3, 4. Really tiny right next to each other. What are all of those x-intercepts? Yeah, I think I can do plus or minus 1, 0. Since there's a positive 1 and a negative 1, I can sort of clean that up a little bit. What's another x-intercept? 2, 0, and 3, 0. Yes. Lots of x-intercepts there. 4 x-intercepts. What's our y-intercept? 6. 0, 6. Beautiful. 0, 6. Number 3 we have how many x-intercepts? 2 x-intercepts, and they are located at?
2, 0.
Negative 4, 0, and 2, 0. Beautiful. Negative 4, 0, and 2, 0. What about y-intercepts? 1. Good. 0, negative 2. 0, negative 2. Excellent, excellent. Okay, 4, 5, and 6. Let's burn through. How many x-intercepts do we have here? None. None. Because it does not cross the x-axis. There are no x-intercepts. What's the y-intercept? 0, 4. 0, 5. 0, 5. Yeah. 1, 2, 3, 4, 5. Yeah, I know. The boxes are small. 0, 1, 2, 3, 4, 5. Number 5. Our x-intercepts. 3, 0. And 7. 7, 0. 1, 2, 3, 4, 5, 6, 7. Y-intercept is 0, negative 6. Beautiful. Y-intercept right here, 0, negative 6. These are 8 by 8 grids. I just figured that out. Just it's done on me. Knowing 8, that would be 7. Okay. A little easier. Ooh, interesting.
Well, they're right on the line.
Are they right on the line? No, they're almost to the line. They are getting infinitely close. Infinitely close here. So they won't ever, yeah, we talked about this yesterday. So this graph is getting infinitely close to the x-axis, but it's not actually going to get there. So in this case, there are none. There are no x-intercepts. And then the same thing is true as this graph is getting closer and closer to the y-axis. It is getting infinitely close. So you got to imagine it's getting so close and so close to that y-axis, but then we just zoom in and look at there's a whole other space. All right, and that's what's really crazy about infinite. It's infinitely close. It's getting closer and closer. We just keep zooming in, and it's like, whoa, I still have so far to go. And then, zoom in a little bit more. We still have so far to go. Never going to get there. So this also has none. No y-intercepts. Okay, so y-intercepts and x-intercepts, super easy to identify. And the zeros is just a fancy name for x-intercepts. So zeros mean the same thing as an x-intercept. The zeros are the points, points, maybe points 1 or points plural, point 1 or point plural, who knows, at which the function crosses the x-axis. It's really just the x-intercepts. So to find the zeros means we're finding the x-intercepts. And so to find the zeros, we set, now when we're looking for zeros or x-intercepts, what is 0? When the y, yeah. So if we want to find the x-intercepts or find the zeros, that's when we're going to find those when the y value is 0. We set y equal to 0. Or we could set f of x equal to 0. Again, that's just fancy notation. It's the fancy y, okay? We set the y value equal to 0, and we are going to solve for x. Again, if we want to find x-intercepts, we got to solve for x. Does that make sense? Yeah. Okay. If we want to find y-intercepts, what do we have to do? X equal to 0. We want to figure out the y, and so we set the x to 0. All right. So it's sort of an opposite sort of thing. I have an old friend who used to do it this way. You know how everything is an XY chart when we're graphing, and if we want to find the intercepts, then we just plug in zeros. We plug in a 0 for the y and figure out what the x is. We plug in a 0 for the x and plug in and figure out the y. What did you say?
Didn't Nacho used to do that too?
Maybe. I don't know.
Yeah.
Oh, yeah, and look for,
Yeah, you saw that.
yeah. Yep.
Ah,
Wait, how do
okay.
you get to the date?
Oh, I'll show you.
I can't, oh, this is my question. I can't do, fractions on my calculator.
Oh,
So when I do second alpha y equals, it won't let me do it. It just sends me straight to the thing.
what is it?
It's an older version,
It's
But-
silver.
but it's,
But his can do it too.
so you might be able to go to the website and, download the newer version. You just have to have the, yeah, you got the, put the cable in, and you could, so you, they might be able to upgrade your software.
Well, I have everything set up. I was installing games on my calculator.
All right. So finding x and y intercepts, very easy graphically. We want to be able to do it algebraically. What time do we get out of here? 56. Oh, okay.
Oh, I love how there's just a separate one for that.
Yeah, that's nice, huh? All right.
Like a separate schedule for that.
Except no teachers have that yet.
Yeah, you're right. It's all right.
Okay. So to find the zeros, which are more commonly known as x-intercepts, how do we find the x-intercepts? Yeah, so again, x-intercepts have something for x and a 0 for y. And that tells us exactly what we need to do to solve. We plug in a 0 for y, okay? If we want to find the y-intercept occur when the x is 0 and we have a number for y. So that again tells us exactly what we need to know. Plug in a 0 for the x and figure out what the y is. Okay, that's always easier, okay? And so if I want to find the zeros, that's telling me to set the y value equal to 0, and that's what this is. So I'm going to say 0 equals the opposite of the absolute value of x minus 5 plus 3. Now, how do we solve absolute value equations? Add the 3 or subtract the 3? Subtract the 3, so we have negative 3 equals the opposite of the absolute value. Oh. And then we need to do what? Divide by the negative. So we get the absolute value of x minus 5 equals now a positive 3. And anytime we have absolute value, what do we have to do? We have two equations. We have two equations to set up. Remember, the guts of our absolute value could have been positive, or the guts of the absolute value could have been negative. The inside could have been negative. It's always going to pop out as a positive 3. So the opposite, the negative guts, become negative x plus 5. All right, so the guts were positive or the guts were negative. Two equations to solve here. We're going to go ahead and add the 5, so we get x equals 8. Subtract the 5 over here. We get negative x equals negative 2, and then x equals 2. Good. All right, so those are our zeros. That means we have 8, 0. The x was 8. The y value was 0. Or we have the x is 2 when the y is 0. Two solutions for those intercepts. The y-intercept is way easier to do. The y-intercept happens when the x is equal to 0. So if I want, all I have to do is plug in a 0 for the x. Let's see, negative absolute value of 0 minus 5 plus 3. So all I'm doing is substituting in a 0 for the x. And we're going to clean it up. 0 minus 5 is negative 5. Good. And then we have, what's the absolute value of negative 5? 5. But it's got a dangling negative in front? So it's still negative 5 plus 3. What is negative 5 plus 3? Negative 2. And again, this is function notation, so we did yesterday. This is the ordered pair, 0, negative 2. 0 for the x, the y value is negative 2. It's an input-output situation. Now again, all of these things we can check on our calculator, and I want you to do that. I want you to know how to check on your calculator. So we want the opposite of the where's absolute value?
Math.
Under the math menu. Math, num, ABS. Math, num, ABS, x minus 5, and then on the outside a plus 3. And then I'm going to do a zoom standard. And we can do a lot of verifying. I can very easily just look maybe, but I can also double check by hitting trace on some of your calculators. I think you can hit trace. And we can just type in x values. So if I type in an 8, then you can see the ordered pair. If I type in an 8, there it is. There's the ordered pair 8, 0. Check. If I type in a 2 and hit enter, again, it shows me the ordered pair, 2, 0. And on the last one, if I type in a 0, because my x is 0, then I have my output of negative 2, 0, negative 2. I'm not sure if that version of the calculator will do that. Does it work?
Only does for the x.
Yes, you can only plug in x values. Yes, yes, so it does work. Good, excellent. So you can always plug in an x value, and then it can verify your order pair pretty easily. All right, let's look at number 8 here. Number 8, again, we want to find the zeros. How do we find the zeros? Set the y equal to 0. And so we have 0 equals 2x squared minus 7x minus 4. How are we going to solve that? No. You could do the quadratic formula. We could complete the square, or we can double bubble. Double bubble. This definitely double bubbles. First times first has to be the first thing. What times what is 2x squared? 2x times x is 2x squared. And then last times last has to be negative 4. What times what is negative 4? Negative 2 times positive 2, or negative 4 times 1, or negative 1 times 4. Okay. Negative 4 on the outside and positive 1 on the inside. How do we know if we did it right? You got to double check the outer and inner product. Always, always. So my outside product here is negative 8x. 2 times negative 4 is negative 8x. And the inside product is 1x. And then 1x and negative 8x gives me my negative 7x. All right. Now, we're not quite done. What do we have to do now that we have our bubbles? Set them to 0. Set each bubble equal to 0 and solve for x. So we set each bubble equal to 0. I'm going to subtract the 1 and divide by 2. So I get x equals negative 1/2. And then how do we get x equals positive 4? Again, moving that 4 over becomes positive. So my zeros, my x-intercepts are negative 1/2, 0. The x was negative 1/2. The y was 0. And my x, 4, 0. The x was 4. The y was 0. So we have our 2 x-intercepts there. Yeah, so now to find the y-intercept. The y-intercept happens when we plug in a 0 for x. So we're going to replace our x's with a 0. So that becomes f of 0 equals 2 times 0 squared minus 7 times 0 minus 4. Is this easy? Yeah. Totally easy. What happens with all those times by zeros? They go away and we're left with negative 4. So we have the ordered pair, 0 for the x, negative 4 for the y. 0, negative 4. Yep. Okay? Latin. So this is stuff we're pretty good at. But again, it is combining all the different ways that we're solving. So that last section of the first chapter is necessary. Let's look at number 9. Again, we want to start with the x-intercepts. How do I find x-intercepts? Y becomes 0. So we have 0 equals x to the 4th minus 5x squared plus 4. Double bubble again. Double bubble. Very good. It's a trinomial. So double bubble. First times first has to be x to the 4th. What times what? Oh, you're ahead of me. What times what is x to the 4th? X squared times x squared gives me x to the 4th. Beautiful. And then last times last has to give me positive 4. What times what is positive 4? Negative 2 times 2 or, negative 2 times negative 2. Or negative 4 times negative 1. And that's the one we want, right?
And then do we have to do that again?
Negative 4 times negative, yes, we do have, well, we don't have to, actually. Could we double bubble these again? Yeah, but we could use the square root method. So we could just set each bubble, x squared minus 4 gets set equal to 0, x squared minus 1 gets set equal to 0, and then we can just square root both sides. So I'm going to move over the 4, we get x squared equals positive 4, and then how do you get rid of the square? Square root, don't forget. Plus or minus, very good. So we get x equals plus or minus 2. On the other side, we're going to move over the 1. So we get x squared equals 1, and then square root both sides. Don't forget, plus or minus. So we get x equals plus or minus 1. How many intercepts do we have here? 4, yeah. I'm going to write them plus or minus 2, 0, and plus or minus 1, 0. Bless you. Again, this is a great one to look at if you wanted to see x to the 4th minus 5x squared plus 4, and I can have a look at that graph, and you can see it's a nice W shape, and there they are, negative 2, negative 1, 1, and 2. So great to verify. Now, of course, if I say I want to see you do it algebraically, what must you show me? You gotta see the work, okay? There's work to be shown. All right, how do we find the y-intercepts? All the x's become zeros. Yeah, so f of 0 becomes 0 to the 4th. Now, do you need to show this step? Probably not. You can jump. It is just 4. So, yes, you could just go right to, that is definitely something you can do in your head, I believe, okay? So that's okay. Again, there's my ordered pair, 0, 4, 0 for the x, 4 for the y-intercept. Oh, there we go. 5 minutes. All the time in the world here, ladies and gentlemen. Number 10. I love this is such good algebra right here. It's everything. All the algebra, all the problems. It's really, really great. All right, how do we find the zeros? Yeah, the y gets to be replaced with a 0, and x cubed minus 6x squared minus 7x. How are we going to solve for x here?
Can you,
greatest common factor, yeah! Greatest common factor. Greatest common factor. Very good. So there's an x that comes out. What's left behind? Good. X squared minus 6x minus 7. Beautiful. And then what do we do? Double bubble from there. Very good. We double bubble that trinomial. Let's see. X times x is x squared. What times what is negative 7? Negative 7 times 1 or negative 1 times positive 7. Which one do we want? Good. Negative 7 and a positive 1. Negative 7 and a positive 1. And then we have to set each thing equal to 0. How many things do we have?
3.
We have 3 things. We got to set each thing equal to 0. So we get x equals 0. We get x equals 7. And we get x equals negative 1. Each thing gets set equal to 0 and solve. Okay? So our x-intercepts are 0, 0, 7, 0, and negative 1, 0.
And our y is
And our y is also 0. Anytime you get an origin, that's also going to double as a y-intercept as well. F of 0 equals 0, so that is 0, 0 as well. Origin is an x and a y-intercept. Okay. All right, questions on those? Good. Let's look at 11. You're doing great. This is a great day. This is my favorite kind of math right here. So exciting. Okay.
Having fun over there.
I love just solving. How do we find the zeros?
Can she bridge common factor again?
We will, yeah. So we're setting our y value to 0. And then we need to take out a GCF, greatest common factor. What is our GCF? Just an x. What's left behind? 3x squared. Good. Plus 13x minus a 10. And then what do we have to do after that? Double bubble. All right. So we're going to double bubble that trinomial again. That's a difficulter one. Good. Yes. 3x times x gets me my 3x squared. Yeah, last times last has to be negative 10. So negative 5 and positive 2? Negative 10 and positive 1? No, yeah, I want, God bless you. The negative 2, yeah, let's do the negative 2 on the inside. Negative 2 and a positive 5. Very good. Negative 2 on the inside, positive 5 on the outside. How do we know if we did this right? The grin. Check the grin. It's a little smile. You see the smile? You see the smile? Okay. So we have the 3 times 5 is 15x, and then a negative 2 times x is negative 2x, and that is where that middle term comes from. So checking the grin. Then what do we need to do?
Make them 0.
Make each thing equal to 0. 3x minus 2 equals 0. X equals negative 5. This one, the 3x minus 2, we have to add the 2, and divide by the 3. Okay. So we get 0, 0, 2/3 0, and negative 5, 0. All right. What's the y-intercept? 0, 0, yeah. Again, if you plug in a 0 for x, you're going to get the 0 for y again as well. Nothing there. All right. Last one. And then I'm not going to pass out your homework. We'll do it tomorrow. Last one. We're going to set the y equal to 0. So we have 0 equals. What do you do first to solve? Add 2. Add the 2. Good. So, and then how do we get rid of the radical?
Would you square it?
Square, yes. Power of 2. Both sides. The square root and the square cancel out. And so we get no plus or minus. Only when we take a even root. Not squaring. Squaring is always going to end up being positive. Right? All right, so then we have 4 equals x plus 1, and then we need to, minus the 1, we get 3. So we have 3, 0. And then to figure out the y-intercept, what are we going to do? Make x equal to 0. So this one, we got to do a little bit of math, just a little. So I plug in a 0 for my x. 0 plus 1 is 1. What's the square root of 1? 1, and 1 minus 2 is negative 1. So we get f of 0, 0, negative 1. Fantastic! Y'all have a good day. We'll see you tomorrow.
Good man.
Wow, right at the bell. That was great.